Greetings, everyone. This is the fifth lab for our computer organization and architecture class. Some people were having trouble, and so I wanted to kind of go over some of it to hopefully explain what's going on. So the first thing they're wanting us to do is set R0 to be the base address. So that means we're setting it to the stack. So for instance, we're just going to set it to wherever the stack pointer is located at. So I have a little example case. I set my stack pointer to happen to be pointing at 80,000. It could be pointing at any number. I just happen to use 80,000 for this one.
Sorry.
If I run the code, your number will be different, but my R0 ends up becoming this crazy number. So this is just happened to be where the stack pointer was looking at. And then these are all just these are all stuff that they gave us. So the first thing other than that is we want to store the values of R1 to the address of R0. So we're going to store, and we're going to store R1 to the base address of R0. So R1 is currently 1, so we're going to store that into the base address of R0. So the base address is here, so we're storing it here, right at this value. Alright. And then this number here is going to increment R0 by 4. So R0 is going to go boop to here. And we can see that here real quick. So R0 is here. 408 is the last, so it should switch to 40C, I believe. Boom, and it does. 40C is the last 3. And boom. Okay, so basically, that command incremented by 4 and stored the value 1, which was R1, into the first position. So now we're here. So now we're going to add 1 to R1. R1 becomes 2. R1 becomes 2. And we're going to compare R1 to R2. So R1 is 2, R2 is 16. So 2 is less than or equal to 16. So it's going to loop. We're back up to here. So basically, it's going to keep doing that same pattern. We're going to set this value to R1. R1 happens to be 2 at the moment. Boom. So now we have there, increment by 4. Now we're here. Yep, 410. Cool. So we're basically just going to keep doing that until all the values are stored. What in the world just happened? How did I even do this? What? Please go back up into here. Thank you. I didn't even know you could do that. Alright, so I'm going to go ahead and jump it down to here. So basically we stored all 16 of these in here. It should be 16, I believe. Yeah. 1 through 16 inclusive. Okay. And then so here we're moving to position. So we're going to basically move to the middle of the array. R1 was serving both as an array counter and as like as just a value we were inputting numbers into. So R1, we're going to go to position 8. So we need to reset the stack. So basically we're going to be like down here by the end of it. We're going to need to reset this back to where the stack was originally pointing at, and then add a certain number. So to get to the 8th position, well, this is array position 7, because that's the value that was storing 8. So array position 7, so that means we're going to need to add 7 to the initial array position to get there. So 7 times 4 is going to be 28, and that's why we have 80,028 here. Just because I started at 80,000 plus 28 will equal this number. So we're just adding 28, and as I said, that's 7 times 4. Alright, so that'll get us into the middle of the array. That's basically going to start us here. So then we're going to load in that value into R4. So what value are we loading in? 8. So boom, we loaded in 8. Hey, it worked. And then we're going to add add this to R3. So R3 initially was 0, so we're going to make that 8 now. Then we're going to compare. This is the same comparison as before, so 8 is less than 16, or less than or equal to. That's true, so we're going to keep looping. Since we ran this instruction, the LDR, we're going to increment this by 4, because that's why we have the 4 there. So same thing as before, as the STR, we're incrementing by 4. Okay, so now we're loading in this next one, so it's 9. So R4 should become 9, and it does. We're going to add that to R3, just like we did before, and boom. So we're basically going to keep looping this until this point where R1 becomes 11, or I guess 17 in hex, or 17 in decimal. It's 11 in hex. So that becomes greater than our R2. So that's why we exit the loop, and we just sit here and stop forever. Okay, so the value we end up getting for R3 is 6C. So 6C in decimal is 108. 6 times 16, and C is 12. So 6 times 16 plus 12 is 108. And that's the number we were expecting here. Yeah. Hopefully that makes sense to everyone. Yeah, I hope you have a wonderful night, and catch you later.